So in this worked example here, we're looking at the time t, the position of the particle of mass 3 kilos is given by this position vector r. We're asked to find the initial position of the particle, the Cartesian equation describing the path of the particle, and also the resultant force. And as soon as I see force, I know that's going to link back to F equals ma, because that's the equation that links force back to anything with our vectors. So that's going to be for C. But for the first one, for part A, we want the initial position of the particle. That's when t equals 0. So we simply want r when t is 0, and that's going to be 0I plus 6 times 1j. So it's going to be, if you wanted to give that in coordinates, it would be at 0, 6, or it would be 0I plus 6j. For part B, the Cartesian equation, remember that the coefficient of I is equal to x, so 3t squared, or 3t cubed, is x. Y is the coefficient of j, 6t cubed plus 1. I can see here that I need t cubed, so I'm just going to solve x for t cubed. T cubed equals x on 3. So that means that y is equal to 6 lots of x on 3 plus 1. 6 divided by 3 is 2, so 2x plus 6. So therefore, our Cartesian equation is 2x plus 6. Alright, for the last part of this question, we need the resultant force. First thing I'm going to do, I've got r of t, I'm just going to write that down up here. I'm just going to expand it. I've just expanded the 6 through this bracket. Now what I'm going to do is I'm going to differentiate, because by differentiating that gives me my velocity vector v. So if I differentiate, I get 9t squared I plus 6 3s are 18t squared. The 6 will disappear. So that's my velocity. And, let's put an I there, we know that if I differentiate again, that's my acceleration vector. 2 times 9, 18t. 2 times 18 is going to be 36tj. That's my acceleration vector. So we know that using our formula we have F equals ma. Here we have A, and we also know in the question the mass is 3. So that means that we have F equals 3 times A. So therefore our force, or our resultant force, is going to be a vector, and it will be 3 lots of 18, which is going to be 54. And 3 lots of 36, which is 108. Now we're asked, 108t. Now we've been asked what is the resultant force acting on the particle when t equals 1. So at t equals 1, that's pretty easy because it's actually just going to be the coefficients left. So that's just going to be 54i plus 108j. And if you wanted to, here we're just asked for the force, so I'm just going to give that. If you asked for the magnitude of the force, it would be a matter of finding the square root of 54 squared plus 108 squared. But for the resultant force, we can give that as a vector. So 54i plus 108j. And so that's using F equals ma, and remembering to differentiate to find your velocity and acceleration vectors so that you can find acceleration to put into that formula.